then I will add 1 to the least significant bit. Okay, so it was 0 and add 1, it will come 1, as you can see here. The same thing for the second example. It's very easy, you can apply. I will take more examples in the next slides. Also, the second bits, okay, the range of the numbers represented by this formula show you how many numbers we can find in the range of the complement. See here, this is the first bit. You can see this is the number, which is 12 in base 10, which is decimal, and 0 mean it is positive, and the negative, what we will do, we invert everything. It means here it will become 1 1 0 0, sorry, okay, and 1 1 1 1. Add 1 here, 1 plus 1, it will be 2. It means 0 1. So here you can see here 0, and 1 is taken as a carrier. Carrier 1 plus 1, it will be 1 here, plus 1 0, again here 0 and 1 taken it, and so on. You got it? This is how we represent second complement. Example, let me take example. Okay, here simplify complement each bit and then add 1 to the results. This is the algorithm we are dealing with. The example here is ask me to find the 2's complement of this number. Here you can see here this number, and also he told me and of its second 2's complement. I mean, after you finish, what is it, the result you got, do the 2's complement. Let me start. This is the number given to me. Okay, as you can see here, I inverted everything. You can see 1 becomes 0 0 1, 1 becomes 0 0 1 0 1, 1 becomes 0 1 becomes 0 0 become 1. This is 1's complement. When I add 1 here to the least significant bit, what will happen? I got what we call it 2's complement. So add 1 plus 0 1, and the remaining I put them here as they are. This is the first half part of the question. He told me the results also do apply 2's complement. So I will take this one here. Invert everything, you got the 1's complement. Add 1, you got this number. Just a minute, this number, it's like returning back to the original number. Yes, when you apply again for the result of 2's complement, you got the original number. Okay, now for the second algorithm for finding the 2's complement, if it is 1 here, you see here 1, keep it and inverse everything. It's like adding 1. You got it? It's like one step. And it's worth mentioning that the range, finite number representation, mean the range, or the computer, the machine of the computer understands the second complement in the range of -2 to power n minus 1 into 2 to power n minus 1 minus 1. This is the range for numbers appearing in this system. Okay? Now it's clear that the second complement mainly used to represent the negative. It's also for the positive, but the negative is the problem, how the machine understands negative numbers. Now up to this point we discussed the sign magnitude and the 1's complement and the second complement. Now more examples, and then we will start the arithmetic operations. First complement could be used for adding number easily. As example, if I want to add 12 plus 1 in decimal, this is a 12 in decimal. How we represent it in binary? This one. I don't need to remind you how we represent it, convert it from 12 from decimal into binary. You know it. Okay. Since it is positive here, in sign number I will add another 0 here to say that this is positive. Now for ones, this is how we represent the number. Okay, enable, I mean, because 4 digits. Okay, and this is positive, I will add another 0 here to say that this is positive. Now adding them, in the last topic we discussed, we learned how to add binary numbers. We add them, 0 plus 1, 1. 0 plus 0, 0. 1 plus 0, 1. 1 plus 0, 1. 0 plus 0, 0. Okay? And this 0 is the carry. We add it here. Since it's 0 is 0, that's it, done. Then 1 plus 0, 0, 1, 1, 0. See here 0? What it tell me? Tell me the final number is positive or negative? You will say directly positive. Correct? Now this represents the answer, which is also correct because 12 plus 1 is 13. 13, this is 1, this is 4, this is 8, which is 13. Now, what about subtraction? Let's see this apply here in subtraction. See, this is 12 minus 1. 12, we mentioned it in the previous, let me say, slide. But minus 1, how we represent it? We do the one's complement. It means I will invert everything. I will add 0, I will invert everything and add 1 here. Add to say this is negative. Okay? So these are 12 minus 1 in binary. I use one's complement. The first number I keep it, but I need it for the second complement. For the second number, it look like this one. I explain here how I got it. Okay, now let's add 0 plus 0, 0. 0 plus 1, 1. 1 plus 1, 0. 1 plus 1, 0. 0 plus 1, sorry, 1 plus 1, sorry, let me back here. 0 plus 0, 0. 0 plus 1, 1. 1 plus 1, 2, which means 0 and 1 here. 1 plus 1 plus 1, 3. It means 1 and 1 plus here. 1 plus 1, 2, which means 0 and 1 here. Now just a minute. This is the carry. I take it here. I add it near the lowest, least significant bit, and add, and I do the final addition. 0 plus 1, 1, 1, 0, 1, 0. Now let me ask you a question here. 0, what does it mean? Positive or negative number? You will say it is positive number, correct? Okay. And you can see here it's correct because it's 11. You see here 1 plus 2 plus 8, it's 11. Now, what about using 2's complement addition? Okay, suppose we want to add two numbers, but we use 2's complement addition. Now, this is the first number. It's written 0011 in binary, and positive the sign, and the same thing for 1 is 1000 with a positive sign. To find the second complement, sorry, second complement. Okay, have a look. Now this is the number. Okay, this is the number. Okay, and this is the one. When we add them, this is if we directly add them together. 0 1 0 0 1 0 1 0. It's easy, right? And this 0 is ignored, the carry, because we have positive, and it's clear it's positive. But if we want to subtract and use, the second complement, the 12 is clear. I don't need to repeat the same discussion. But for the minus 1, you see here, what I will use? I will use the second complement. It means I convert everything, the first complement, which will become 0, 1, 1, 1. And then I add 1 to become 1, 1, 1, 1. And there here 1 to say that this is negative number. Sorry, negative number. You see here? The same one I just discussed. Now we add 0 plus 1, 1. 0 plus 1, 1. 1 plus 1, 2. It means 0 and 1 here. 1 plus 1 plus 1, 3. It means 1 and 1 here. 1 plus 0 plus 1, it means 2. It means 0 and 1 here. See, this one is the carry. You ignore it. We don't need it because we have here the number, and its sign is 0, which means positive. Easy? Okay. Now more examples. 13 minus 5. You see here 13 is clear. Okay, it's positive. It's positive. For this one, we use the 2's complement. We invert everything. It becomes 0, 1, 0, 1, and I add 1 here for negative. Then we add 1 here into the least significant bit, 1 plus 0, 1, so we got this number. Now let's add together. This is my number after I found the 2's complement, and this is the original number I would like to subtract from. Now 1 minus 1, 0, 0 minus 1, cannot, we borrow. It will be 2 minus 1, okay, 1 minus, sorry, this is addition, sorry. 1 plus 1, 2, it means 0, 1 here. 1 plus 1, 2, 0, 1 here. 1 plus 1 plus 0, 2, 0, 1 here. 1 plus 1 plus 1, 3, 1, 1 here. 1 plus 0 plus 1, 2, it means 0, 1 here. This is the carry. See? And this is my number, which is clear. 13 minus 5 is 8, and this is 8. Okay? More example, as you can see here, more example, it's clear how we got it in decimal. Another example, what if I have 5 minus 12? You can see here, 5 is clear, it's because the positive number, but let's come to the minus 12. Minus 12 represented in this way in binary, okay, in sign, you can see here the sign negative. Then I found the second, the 2's complement. I don't need to explain again how we do the 2's complement, because you understand that we invert. We got the fifth, the 1's complement. We add 1 to the least significant bit, then we got it as a 2's complement. Now let's add them together. Here, this is the 2's complement. This is the positive number. I don't need anything here. 1 plus 0, 0. 0 plus 0, 0. 1 plus 1, 2. It means 0, 1 here. 1 plus 0 plus 0, 1. 0 plus 1, 1. You can see here, this is the number, and its sign is 1. Okay, which means it's negative, which is clear because we know that 5 minus 12 is minus 7, and this is minus 7. You can see here, this is 1, and this is 8 in binary, okay, in decimal, sorry. Then we have minus 7. Now, the summary of what we discussed in this topic, binary numbers can be represented in octal and hexadecimal because it's the base. Easy to convert binary, between binary, octal, and hexadecimal, they are related. Signed number represented in signed magnitude, or 1's complement or 2's complement. 2's complement, most important, only 1 representation for 0, and 0 for positive, 1 for negative. Important to understand treatment of sign bit for 1's and 2's complement. See you in the next topic.